Welcome to week number 3 of Math 150 here at Franklin. This is the first video for week 3 intended for you to watch before we meet for our weekly meeting. In this week, we get to learn about the Cartesian coordinate system. It's basically how to read a map. If you've ever played Battleship and you give your partner B4, one is a column location, the other is a horizontal location, and you need two pieces of information to identify the one point on your map. That's what we're working on this week with linear equations. We're finding equations that have two variables, an x and a y. The x corresponds to the horizontal x number line or x-axis. The y value is the vertical change, and that's the y number line, also called the y-axis. These are the 4 sections you'll be going through with our book and working within ALEKS. The 2 biggest equations you need to take from this week are the slope-intercept form and the slope. Slope-intercept form of a linear equation is given that name because it tells you the slope and the y-intercept. If you know one point on a line and you know the steepness of the line, you're able to draw that line. When you draw a line, you're drawing an infinite number of points. So given an x number line with a 0 right there, and then you draw your y number line vertically, again with 0 right there, that origin is the point 0, 0. These are called ordered pairs of number because the order matters. The first number is always the x coordinate. It's the direction and how many spaces you move horizontally in the x direction. The second number is always the y coordinate. If you're military and using maps, instead of longitude and latitude, we have x and y. One being the horizontal, the other being the vertical. The other equation that you'll use quite a bit this week is the equation that given 2 points, you can find the slope or the steepness of the line. I want you to notice that these subscripts, the writing below the line, these subscripts are not telling you to multiply or square root. They have no mathematical value. They have a very practical value. It's to tell you that x subscript 1 and x subscript 2 are different x variables. Now that we're talking about a two-dimensional plane or a piece of paper or a map, x being the first coordinate that tells you how far right and left, east and west in the horizontal direction to move from the origin, we need to know that x subscript 1 and x subscript 2 are different variables. Yet we want to use the variable x because that tells us our horizontal movement. All right, again, this is the origin. Again, if you've never plotted points in the Cartesian coordinate system or the rectangular coordinate system, please watch the other video I've provided. It will go into great detail. Quick example, if I give you the point 3, 4, you will go to the right 3, up 4, and that would be your point. That has the address or location 3, 4. The order matters because if I had given you the coordinates 4, 3, you would go to the right 4 and up 3, and it would be over here. Let me get this a little bit neater. I'll pull the graph up in a moment. There is your 3, 4. And then in green is over 4, up 3. And those would be your coordinate points. All right, we'll talk about slope. Point slope comes in week 4, but if you learn it in week 3 and want to use it on test number 1, you can. If you're familiar with the point slope formula of a line, you are welcome to use that anytime you'd like. We usually write it as y minus a specific y is the same thing as x minus a specific x. And m represents your slope. M is not a point on the line. M just tells you how steep the line is. So here we are plotting points on the left. We have 4, 5. When you use Desmos.com, and I strongly encourage you to use Desmos.com as you're doing your homework, do not let it become a crutch, but use it like a tool to help you visualize what it is you're doing. This point right here is found at location or address 4, 5, because the first number is your x, the second number is your y. In blue, -3, 6, start at the origin, go 1, 2, 3.5, and up 6. And that is the location or the coordinate of -3.5, 6. All right, again, you can have this document downloaded. Check the coordinates. Make sure you understand how to plot points on a graph. Now, when you write a pair of numbers as an ordered pair, the order matters. The two numbers written within parentheses and separated by a comma are called an ordered pair. We also use this notation for interval notation, but given the context of the math problem and the math question, you'll know whether we're talking about an ordered pair or an interval of numbers. When you read this 3, -4, you're saying the x value is equal to 3 when the y value is equal to -4. So instead of writing out that entire purple sentence in English, mathematically, we just write parenthesis 3, -4, close parenthesis, and it tells the same information. When you're graphing an ordered pair, the first number tells you how far to move in the x direction. The second number tells you how far to move in the y direction. Understanding the relationship between a linear equation and its graph. This is the most important piece for this entire week. You are showing us the solution, what we've worked for up until then. I've asked you to solve equations. That's to tell me the numerical values of the variable that will make the equation true. So if I gave you the equation 5x plus 10 equals 40, you would subtract 10 from both sides because you know you can do whatever you want to both sides of an equation. So if you subtract 10 from both sides, you've rewritten the equation. And we know that 5x equal to 30 is the same equation as 5x plus 10 equal 40. You now divide both sides by 5 and find out that x equals 6. All three of these equations are telling the exact same story. The reason we rewrite it to be x equals 6 is because that's a very obvious, easy equation to understand. If I tell you, hey, x equals 6, and the reason you're allowed to give this back to me as your final answer is we're supposed to assume anybody looking at this equation here in yellow, x equals 6, knows what is the mystery that when we put it into the variable x, it will have the same value as 6. Well, the only number that is going to make that true is 6. So that's how we know x equals 6 is our final answer. Then we've switched it up. So for number 2, we then give 5x plus 10 is less than or equal to 40. Well, now there will be more numbers that make this equation true. I'm now asking you to give me all of the numbers when multiplied by 5 and added to 10 will be less than or equal to 40. Subtract 10 from both sides, and we know 5x is less than 30. We can do whatever we want to both sides. Now, when we divide by our 5, we have an inequality We are multiplying or dividing, so we ask ourselves if we flip the direction of the inequality, and the answer is no, because what we did to both sides of the equation was to divide by a positive 5. So now if I were to try and represent all of the solutions, it would be much easier for me to graph. So if I have 0 on my X number line, and I have a 6 on my X number line, I'm looking for all of the points that will make that equation true. Well, 6 is less than or equal to 6, so that means 6 makes my equation true. I also know that every number less than 6, so I need to put a dot on every number that could go into that box and make the equation true. Well, 5.5, 4, 4.2, 3, 1, 0, and all of the fractions and decimals in between. I also know if I were to pick a -6 over here and I have -6 on my number line, I also know negative, and all of the negative numbers are less than 6. So once I put a dot on every single point that makes my equation true, I end up having an infinite number of points that make the equation true. That's why when we graph, we put a line and an arrow going in a direction to show, hey, it keeps going on forever. Again, on these number lines, off to the right continually gets larger and larger, so we say it approaches infinity. To the left, our number line gets infinitely smaller, so we say it approaches negative infinity to the left, positive infinity to the right. And here is our number line, and all of those green dots are solutions, and once I put a dot everywhere, it's going to look like a ray with a closed circle. Now we're advancing between one-dimensional analysis, and we're now in step 3, 2 dimensions. We now have an equation that has an X and a Y value. Now my solutions have to have 2 answers. They have to have an X and a Y. Given this equation, X plus Y equals 20, I need you to give me all of the pairs of numbers that will add together and equal 20. That's an infinite number of numbers. You do not want to have to write out all of the ordered pairs that when X plus Y equals 20, it's true. We have 1 and 19, we have 5 plus 15, we have 1.9 plus, you can add all the fractions and decimals involved that will, pairs of numbers that will add to be 20. Then you've got negative numbers like -40 plus 60, that will equal 20. So that means the ordered pair -40 and 60 will make the equation true. If you had to list all of the solutions, you would never finish. So what we do is we graph. Drawing the graph is a way to show an infinite number of solutions. And how we want you to graph is we want you to figure out the shortcuts and easy ways to do it. The reason these are called pattern recognition. The reason these are called linear equations is because all of the solutions, all of the pairs of numbers that add to be 20 will form a straight line. Say it again. All of the pairs of numbers that add to be 20 will form a straight line. 515 from the origin over 5 up 15, and there we are. 218 from the origin over 2 and up 18, there we are. On a piece of paper, anytime you put 2 dots on a piece of paper, there is only one line that can go through those 2 dots, one straight line. So all you really need to find are 2 solutions to your linear equation. Once you plot those 2 points on your graph, you can then draw a straight line. What we're going to do is give you 2 points and ask you to tell us the equation of the line. So we're given 2 points, -6, 4, and 4, -11. Personally, I'm a very visual processor and visual learner, so I would like to sketch that. Okay, so here's my X number line. Here's my Y number line. If this is -5, +5, and then my Y number line is the vertical. So if this would be -5, then about here would be -10. Put the numbers on the left side so I can use that space to write. Get a picture of what's going on. This is where I encourage you to have a tab up that is Desmos.com. Desmos will do this quite accurately for you. My goal is that you recognize and that it clicks that all of these dots you're putting on paper are XY pairs of numbers that make the equation true. So here, graphing -6, 4, -6 would be to the left, and then +4 would be somewhere about here. That would be an approximation for -6, 4. And then I have the point 4, -11. So I would go over 4 and then down 11. That would put me right about here at 4, -11. So that means my line is going to go between the red dot of -6, 4 and the green dot of 4, -11. And then all of the XY pairs that will make the equation true will lie on that blue line. So given 2 points, find the equation of a line. The 2 points are -6, 4 and 4, -11. Find the equation of the line that contains all of these blue points. That's what you're asked to find. Now, using our slope formula, this one down here, the slope is the ratio of the change in Y, your vertical change, divided by your change in X. It does not matter which point you define as point 1 and point 2. For the sake of this equation, I let this one be point 1. And I let this one, 4, -11, be point 2. So here's my 4, -11, X subscript 2, Y subscript 2. And my -6, 4 is X subscript 1, Y subscript 1. I usually do a circle, my Y sub 2 minus Y sub 1. If this is my Y sub 2, then I have -11 minus the other Y value, which is 4. I started with -11, so I'll go to its partner, which is 4. Minus the other X value, which is -6. Notice this is minus a -6. Again, minus a -6. Minus a negative is the same thing as adding. So -11 minus 4, I've lost 11, and I lose 4 more. I've lost a total of 15. My denominator, 4 plus 6, is 10. Those are both divisible by 5, so I reduce, and I have -3/2. You can write it as -1.2, but my slope is a ratio of the vertical change, the change in the Y direction, over the change in the X direction. That triangle means delta. It's a Greek D for delta, the change in Y over the change in X. So my slope is -3/2. I found my M. My M is -3/2. Step 2, find my B, find my Y intercept. We're given the equation Y equals mx plus B. Actually, we're expected to have memorized the equation Y equals mx plus B. So please make sure you memorize the slope intercept. It's called slope intercept because M is your slope B is your y-intercept. Pick either point you want. It doesn't matter. I'll go ahead and pick the green point. 4, -11. So my x is 4, my y is -11, and my slope is -3/2. It does not matter which point you pick. Both points lie on the blue line we're trying to find. So now I'm going to plug this in. I have the slope-intercept form, and I strongly encourage you to write y = mx plus b on every single one of your homework assignments. So my y is -11. Go back to green. Again, I chose to pick the point for -11. It doesn't matter which one. You can pick the other point, go through the same process. You will get the same equation of the line here at the end. So now I'm going to plug the numbers in. My y is -11. My m is -3/2. My x, one of the specific values for x is 4, when the specific value for y is -11. I now work this out. I have -11. Multiplying fractions, if they're giving you a problem, -3/2 times 4. So I didn't have to rewrite that. I've done it here. I'm now going to add 6 to both sides of my equation. -11 plus 6. I've lost 11 and I've gained 6. Give me 5 that I've lost. I've lost $11 and I get $6 back. I usually use a cursive B so it does not look like the number 6. Now that I have the y-intercept, B, I know that the point 0, -5 is my y-intercept. That's where my line will intersect or intercept the x-axis. Back to my drawing, and if you look up here, even my approximation showed that my y-intercept was approximately 0, -5. We've just proven that actually my blue line will cross the y-axis. It will intercept the y-axis at 0, 5. So the final part, step 3, write the equation. B is -5. M is -3/2. I now have all of the information that I need to write the equation of the line through the two given points. Y equals -3/2 x minus 5. -3/2 x minus 5. And that's what you will put into ALEKS. This is the equation of the line that goes through the two given points. Given the points, again, to summarize, this does get a lot easier once you already know the process. We were given these points here, -6, 4, and 4, 11. We plotted those points and found they were up here and down here. We then drew the blue line to show the approximation of where all of the points on our line will be. Given 2 points, step 1 is find your slope. Step 2 is find your B, find your y-intercept. Our y-intercept was -5. Once you have the steepness of the line and you have one point on the line, like 0, -5, you can then write the equation of the line. Y equals m times x plus b. The y value equals the slope m times your variable x plus b, your y-intercept. Y equals mx plus b. X and b must be a fixed number in your equation. Y and x will remain variables in your equation of the line. So y equals some number times x plus some number is your slope intercept form of the equation of the line. Keep up the good work and keep the questions coming.